So today we continue studying problem solving, but today's problems are called excess and deficiency problems, or as they are also called, to determine the substance that is in shortage, that is in a certain limiting state. The conditions of our problem. We are given a mass of phosphorus, oxygen, and given the following scheme of chemical reaction, interaction of phosphorus and oxygen. We get P2O5, phosphorus oxide of valence 5. So before we solve the problem, we need to equate the equation. To do this, we will start with oxygen, equating it first, and then phosphorus already. That's it, our equation is ready. So how are we going to solve the problem? Let's see. By the condition of our problem, we are given phosphorus, we are given oxygen, and the first question is, what is our substance in deficiency or substance in limitation? And we are also asked how much P2O5 will be obtained during the reaction. As usual, we're going to solve in the mole method. We'll sign here 4 moles. We'll sign 5 moles here. That's the resulting numbers from the coefficient. And here we have 2 moles. And now let's see, by the condition of our problem, we're given the masses of phosphorus and oxygen. Then let us find how much that is in moles. So we'll find that for phosphorus as well, so we get the number of moles. And in this case, the mass is divided by the molar mass. For phosphorus, it will be 31 grams divided by 31, because phosphorus, according to the periodic table, has exactly this mass, and so we will have 1 mole of phosphorus according to the condition of our task. In the same way, let's calculate the moles for oxygen. And in this case, it will be 32 grams divided by the molar mass of oxygen, and it will be equal to 32 grams per mole. So that's 1 mole. Let's sign this here. Formally, it turns out, look what picture. We have the number of moles of each of the reagents, 1 mole each. It would seem that we could say, yes, their number of moles is the same, and it means that none of the substances is taken, neither more nor less. They are taken in equal amounts, but it is not so. The fact is that our substances react in certain mole ratios. Then we have to establish which substance is taken more than is required. We'll do the following calculation, done in the most rational way. It'll be 1 mole for phosphorus. Divided by 4 moles for phosphorus, notice I'm taking into account the ratio. And for oxygen, it's 1 mole over 5 moles. And if we do the math, the first number we have is 0.25. That's the so-called mole factor. And here we have 0.2, and as we understand, 0.2 is less than 0.25. Then we can put this sign more or less and say that our substance that is in shortage, or being a substance in a limited state, we have oxygen, and then the substance that's taken more than that will be the substance in excess, and this substance we will have in this case phosphorus, and this substance is taken more than necessary, that is, it is taken in excess. Now further, how do we further decide? The next step, we will find how much of our phosphorus oxide should be obtained. Here above phosphorus oxide, I will write X mole. And on what substance we should make calculation? Naturally, on that which is taken in the smallest quantity, because there is no more oxygen, and consequently the greater quantity will not be possible to react with phosphorus, which is required still for this oxygen is more, and then we get the proportion of 1 mole of oxygen to 5 moles. and refers as x mole for P2O5 refers to 2 moles. Hence, x is 0 to 4 moles. That's for P2O5. But since we are asked about P2O5 mass, then we have one last thing to do: calculate the mass of P2O5. And for this, we'll use the formula molar mass P2O5 times the amount of matter. P2O5, we have the weight of the periodic system phosphorus, 31 times 2, oxygen 16 times 5. This will be 142 grams. Converted to moles and multiplied by 0.4 moles. Mole and mole reduced, and we get that the substance P2O5 will be 56.8 tenths of a gram. And that's our answer. Then the first question is, what is the deficiency substance in this case? That is the limited substance. It will be oxygen. This very substance is taken in a smaller amount. And then the substance in excess is phosphorus. The second question, how much P2O5 was obtained? We found, and I pay your attention, the calculation should be carried out strictly on the substance taken in the limited state. So it is 56 and 8 to be obtained. But if we took the calculation through phosphorus, this figure would be different, but it would be an incorrect result, because such a calculation would not work, only because in this case oxygen is taken not more but less. So such a calculation would be incorrect and should not be done. And that's it for today. Goodbye.